Hello again. For this video we're going to discuss how to graph quadratics from the standard form of ax squared plus bx plus c equal to 0. A few vocabulary words here. Axis of symmetry. Got to know what symmetry means. We're also going to talk about the vertex, and you'll see here I have an x and a y for the vertex because it is a location on the graph, and the x coordinate of the vertex can be calculated by opposite of b over 2a from the standard form. And the traditional way of calculating the y value for this would be to take this number here, substitute in for x here, and let it output what the value of y is. However, you can calculate the y coordinate of the vertex directly by doing this little calculation, c minus b squared over 4a. And I will use this in a little bit when we start graphing. You also need to know what the word reflection means, and that all of our graphs here create a parabola. First of all, we have a u-shaped curve, and this is called a parabola, so this right here is a parabola. Axis of symmetry is an important concept here. You can see here I have a curve, and down here we have the vertex. That's the low point on this one. The vertex is the change of direction in the graph. And I drew a dotted line that went right through that vertex vertically. And this line, AOS, or axis of symmetry, is defined by a vertical line at x equals opposite of b over 2a. But here's where the idea of symmetry comes into play. If you look at this dot right here, you'll notice that it is 2 units, 1, 2, to the right of the axis of symmetry, and this dot over here is also 2 units to the left, and the same thing down here on this dot. So this is 1 unit to the right, this one is 1 unit to the left. So everything on this side of the curve is mirrored or reflected across to this side. Now, as far as the graphing goes, here's a couple of steps. First, we want to calculate the location of the vertex. Second, we want to make a table of values using 1 or 2 domain values, which are the x values, to the right or to the left of the axis of symmetry. After we do that, we want to graph the vertex and the 1 or the 2 points, depending on how we chose, from our table of values. So we'll have at least 2, maybe 3 points on the graph. Then all we got to do is reflect those points across the axis of symmetry and then sketch the parabola. Okay, so here's first couple of examples. We've got 2 parabolas here, 2x squared plus 8x plus 1 and negative 2x squared plus 8x minus 3. And this is where our table of values are going to be. But the first thing I'm going to do is calculate the location of the vertex of each one. So here's our first equation, and I've already identified the a, the b, and the c values. So the vertex is going to be located at opposite of b over 2a for the x value, and for the y value, c minus b squared over 4a. Okay, so I'm going to calculate the x first, so that's going to be opposite of b, or negative 8, over 2 times a, 2 times 2 is going to give me 4, so it's negative 8 over 4. And negative 8 divided by 4 gives me an x coordinate of 2. So I know that this vertex is located at 2, comma. Now I got to go calculate the y coordinate. The y coordinate starts with c, which is 1, minus, and then our b squared is going to be 8 squared, and then 4 times 2 is going to give us 8 there also. So I'm going to simplify that to 1 minus 64 over 8. Then, of course, this reduces to 8, so 1 minus, that should be an 8. And then 1 minus 8 gives us a negative 7, so the y coordinate is at negative 7. So I know that this graph here has a vertex located at positive 2, negative 7. Actually, that's not positive 2, that's a negative 2. I just noticed that. That's negative 2, negative 7. So go back to my table over here. If I have an input of negative 2, that's x, my output, which is also my y value, will give me a negative 7. Now I want to pick 1 or 2 more values here to graph, and I want to pick them either to the right or to the left of this number here, which is my line of symmetry. So my line of symmetry is actually defined by x equals negative 2, or I called it line of symmetry. It's actually axis of symmetry. And I like to pick 0, and I'm also going to pick negative 1, which is between these two. So these two numbers are to the right of negative 2. So if I put a 0 in place of x here and calculate, it will output a positive 1. If I put a negative 1 here and calculate that, it'll output a negative 5. All I got to do now is go graph those. So starting with my vertex at -2, -1, 2, 3, 4, 5, 6, 7. Then graph 0, 1, which is here. And then -1, -5, -1, 1, 2, 3, 4, 5. And I'm going to go ahead and draw a little line of symmetry here just to help me graph this right there. So this one's going to be curved up that way. And then I'm going to reflect these points. So this is 1 unit over to the right. I'm going to make that 1 unit left. This is 2 to the right. I'm going to make that 2 to the left of my line of symmetry. And then I can just eyeball the curve on this side. And the curve doesn't have to be perfect. It has to be in the relative correct position. But these dots here should be accurate. For our second equation, we've already got the variables or the numbers a, b, and c identified here. So we're going to calculate the x-coordinate of the vertex first, which is opposite of b, which is -8 over 2 times a, 2 times -2. There's my a. That's going to give me -8 over -4. And this time we will get a +2, so I know the vertex is located at 2 comma something. Now the y-coordinate is going to be located at c minus b squared over 4a. So c is going to be -3 minus b squared is 8 to the second, and the 4 times a is -2, so 4 times -2 here. Reduce that a little bit. So -3 minus, that's going to give me 64 over -8. Well, minus a negative here is really plus a positive. And I'm going to reduce that again, so it's -3, 64 over 8 is plus 8. And of course that combines to make 5, so now my vertex is located at 2, 5. So I'll come up here. If I have an input or domain of 2, my output, or f of x, would be 5. Again, that's the same as the y value. And I like to choose 0, and the number that's between 2 and 0 would be a 1. So if I put a 0 here and here, my output will end up being -3. And if I put a 1 here and here, my output will end up being a +3. So go ahead and graph this. And the first one is going to be 2, 5, 1, 2, 1, 2, 3, 4, 5. 0, -3, 1, 2, 3, 0, -3. And then 1, 3, 1, 1, 2, 3. And you notice this is a negative here, so that means my graph is going to be inverted. I'm going to draw my line of symmetry, or axis of symmetry, and just reflect these points across. So this one's 1 over to this side, this one's 2 over to this side, and just eyeball a curve on there. And that's all you really have to do. As long as these points are accurate, your curve can be off a little bit.